Alright, so why don't you take a second, try and do the problem, and then once you have attempted the problem, we can work on it together. Alright, let's look at it. So it says in the xy plane, line K is a line that does not pass through the origin. So that's what we're given. So I already want to make sure I have a xy plane going on here, just to make sure I know what's going on. I'll have some sort of, there's the y and there's the x. So that's a good way to start. Now it says, which of the following statements individually, so by itself, provides sufficient additional information to conclude that the slope of line K is negative. So we need to make sure that the slope is negative. Alright, so that's the change in y over the change in x has got to be negative, or it's got to be something where it's going down. That's the whole idea. Something like this. Alright, so that's what we're looking for. Could be anywhere, could be less drastic, more drastic, but we want to make sure it's going down of some sort. Alright, so let's look at A. A says the x-intercept of line K is twice the y-intercept of line K. Alright, so what is the intercept? So when you have this standard y equals mx plus b formula, the x-intercept is what happens where the line crosses the x-axis. So here, somewhere here, it could cross anywhere. But that's also a situation where your y value, because remember when you look at a point and you look at where is the y value on this, the y value right here, that tells you how far up and down you go. So for instance, if you got 2, 4, this is going to be 1, 2, 1, 2, 3, 4 right there. So that 4 tells you you want to go up 4. So a x-intercept is where it crosses the x-axis, which is actually where y is equal to 0. Right? So if a line crosses right here, the y value, which is how far up and down you go, that's right at 0. Alright, so that's what we're looking for. Alright, and that's why you go something, that's why y would equal 0, and then you can actually solve for x, usually, when you put in y equals 0 right there. Alright, so that's what we're looking for. Alright, so we said wherever the x-intercept of line K is, so let's say it crosses somewhere like here, the y-intercept is twice of that. So let's say this is something like 5. Okay, well then y-intercept would be 10. Alright, so that means that the line goes like that. Now, if a line goes like that, obviously it's going to be negative, right? So, but that's not always the case. For instance, you could have different scenarios. So, x could be negative. Sorry, this could be at negative 5. Alright, so that could be the x-intercept is at negative 5. Now, if the x-intercept is negative 5, then twice of that is going to be your y-intercept, and that's negative 10. So that gets down to negative 10. And now you have a line that goes like this. Now, you notice is that for both of these scenarios, the slope is going down. Alright, now the only other situation for the x, so x can either be negative or positive, or it can be 0, but it can't be 0 because we've already said it doesn't go through the origin. So we've basically exhausted our potential examples of x. It can either be negative or positive, and in both of those scenarios, we see that the slope is negative for those lines. So A actually does work. We can say that, yep, you can see that no matter what x value you use, and you could try different x values if you want it, it will probably be the same always. You'll have it here, and then it'll come even further down this way, and you'll have a line that goes like that. Or if you have it positive, y will be very high, and it'll go down like that. So it'll always be negative. So the answer for that is going to be that yes, A is enough by itself. Alright, now let's look at the second one. The product of the x-intercept and the y-intercept of line K is positive. So what does it mean to have the product of something? Well, the product of something is where you multiply it. You multiply two things. And they want the product of the x-intercept. So an x-intercept is the point where it crosses the line, right? So for instance, if a line was doing something like this, the x-intercept would be 5, right? So that's what we're looking for. So let's take the x-intercept of 5. Now let's get rid of that. Let's get rid of that line first. Alright, let's say the x-intercept is 5. Then the product of the x and the y-intercept is positive. Alright, so if x is 5, then x is positive. So what does this have to be in order for it to be positive? Now remember, this is the x-intercept. This is going to be the y-intercept. Alright, and that's what we got that from the product of the x-intercept and the y-intercept, which is the product of this and this, is positive. Okay, so whenever you have two things multiplying and they're either positive or negative, you can know something about the things that are being multiplied. So for instance, two positives multiplied together is always going to be positive. Similarly, two negatives multiplied together will always be positive, right? So negative 2 times negative 2 is 4. 2 times 2 is 4. Things like that. The only way you can get a negative is you need to have one of the things being multiplied being negative and the other thing being positive. Then you get a negative. Okay? So that's what we're at. So we now know that if these two things multiplied is going to be a positive number of some sort, and this is positive, then this has to be positive. Because if it's not, then you'll get a negative. Positive times a positive equals a positive. If this was negative, you have a positive times a negative, that would become a negative. So we don't have that. So if x is positive, the x-intercept is positive, then the y-intercept also has to be positive. Now let's think about that scenario. If the x-intercept is positive, let's put it at 5, then the y-intercept also has to be positive. We don't know where it is. It could be anywhere on this line. But no matter where you are on this line, if you're positive and you draw a line through x, through the 5x intercept, you can see all of these slopes. All of these slopes are negative. So what we're sitting at is, again, another situation where this is going to be a negative slope always. Now that was only when we tested again x equals 5, which is a positive slope. Let's try a negative slope. If the intercept. If the x-intercept is negative, what does the y-intercept have to be in order for the product to be positive? Well, the y-intercept has to also be negative, right? Because when you have a negative, you have to multiply it by another negative to make it positive. You can't multiply it by a positive. So if x is negative, let's put it here, anywhere. I don't know where that is. It looks like it might be negative 4 or something like that, but let's just say whatever it is. The y value has to be negative as well, the y-intercept. So, and you can put it here, 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 here. Again, you run into the same situation, which is when you draw these lines, and they go through that intercept, pretend that all those lines go through that intercept. Again, you look at negative slopes. This one is pretty close to horizontal, but it's actually not. It's still negative, just a shallow slope. That's, again, always going to be negative. So now, again, we've tested when x is negative, when the x-intercept's negative, again, the slope will be negative, and when the x-intercept is positive, again, the slope will be negative. So because we've tested all our potential solutions, we can do the same thing with the y-intercept and see the exact same result, just the opposite direction. We have now shown that actually B is also enough information. So now we know that A and B are both enough information by themselves to show that the slope is going to be negative. All right, now let's look at letter C. See what we can find. All right, letter C says. No, I should be using that in just a second. Letter C says that A minus R multiplied by B minus S is less than 0, where these numbers relate to two different points on the line. So K passes through points A and B, K passes through points A, B, and RS, wherever they could be. They could be anywhere. But there's 2 points. All right, and the multiplication of these 2 points is less than 0. Or not the multiplication of these 2 points. A minus R multiplied by B minus S is less than 0. Now, let's look at these individual points, or these individual parts that because they've actually done us a favor, and they've put these two things together. They've put A minus R together, and they put B minus S together, and they've had them multiplied by each other, and they say that they're less than 0. Another way to say less than 0 is negative. So, A minus R, what does that mean? What does that represent? Why would they put it together like this? Well, let's look at what A and R are. A is the x value of this point, right? Because the point has an x value and a y value. And then R is the x value of this point. So they're both x values. What you're looking at is one x value minus the other. Now, if this is let's call this the first point, and this is the second point, what you're getting here when you do this x minus this x, or A minus R, is you're actually getting your change in x as you go from this point to this point. That's your change in x. Now, what is this? This right here is going to be your B minus S. B is the y value here, and S is the y value here. That should have been a y, sorry. S is the y value here. So there you go. So now we're seeing that B minus X, B minus S is actually your change in y. So what they're saying is your change in X times your change in y has to be less than 0, or has to be negative. All right, now let's think about these properties that we have here. Your change in x multiplied by your change in y is negative. All right, now, what does that mean? Well, if you change, so what we have here is we have that if this is positive, then this has to be negative, right? Because otherwise this will be negative. Otherwise this will be positive, right? We have a positive multiplied by a positive equals a positive. So if this is positive, then this has to be negative. Because if it's positive, then this is going to be positive, and we can't have that. Because we know that your change in x multiplied by your change in y is going to be negative. So if this is x, if this is positive, this is negative. Similarly, if this is negative, this has to be positive. And the opposite is true. If this is negative, this has to be positive. This is positive, this has to be negative. So we know all that. So what can we do with the fact that we know that your change in x and your change in y have to be the opposite direction? Well, what we can do is we can actually use this to find out what the slope is going to be for the line. Now, why is that? Well, it's because the thing I actually erased previously, which is that your slope is known as your change in x over your change in y. Triangle notation basically means change whenever you see something like that, and at least it's involved in coordinate plane situations. Triangles can mean different things in other situations. Okay, so what we're doing here is we now are looking at the change in y of the change of x. Now this is your slope. This is the definition of a slope. It's your change in y, x over your change in y. Sorry, I think I should say that a little bit differently. That's not actually correct. It is your change in y over your change in x. Actually, no, hold on, let me just look that up. I just had to look it up really quick. It is change in y over change in x, actually. I always get those two confused. But if it is the change in y over the change in x, and we know that they have to be the opposite sign, then you either have a positive over a negative, or you have a negative over a positive, right? Because the change in y, if it's negative, the change in x has to be positive, and vice versa. So, whenever you have a positive divided by a negative, or negative by a positive, you have the same result as you have here. You have a negative. Alright, so that means that your overall slope, which is your change in y over your change in x, will either be positive divided by a negative, or a negative divided by a positive, which means that it will be negative. So therefore, C works as well. For all three of these, you have enough information with that single line of information in order to determine whether the slope is positive or negative, and in fact, specifically to determine that the slope is negative.